All right, this video is filmed before a live studio audience. Here we go. We have number 4 on the review for Unit 0, and we're going to work backwards here. Let's do this one first. Before we do anything, let's realize what this means, this line that tells us that the 5 only repeats. So we have 0.17555, and so on. Okay, so the 5 only repeats. So the very first thing in these repeating decimal problems that you should do is you should let x equal what you're trying to figure out. Step 1. Step 2, figure out how many digits are repeating. 1 digit is repeating, the 5. When 1 digit is repeating, you multiply both sides by 10. What that does is move the decimal point 1 space to the right, and it really just gives you a new number to work with so that we can then subtract and get the repeating part to cancel out. While we're here, let's go over to the middle one and show you how this problem would be a little bit different. For that one, 175, all 3 digits are repeating. So instead of multiplying both sides by 10, you multiply by 10 cubed, or 1,000. That's going to make this 175.175, 175, 175, and that 175 is what repeats. Okay? Now we'll go back to the red one. You can see how the two problems are different. The one on the right, we multiplied by 10. The one on the left, we multiplied by 1,000. Okay? So back to red. What we do next is we subtract this 1x from the left side, while you subtract 0.175 repeating from the right side, with the 5 being the repeater. Okay, so let's put a line under it to show that we're subtracting. 10x take away 1x isn't 10. 10x take away 1x is 9x. Now here's where these problems are a little trickier when it's only 1 digit repeating. 1.75 with the 5 repeating, we could continue to write 5s for a really long time, right? In fact, you could write 5s forever. That's what it means. Down here, it's 0.1755555. What I want you to notice is that you have your 7 and your 1 lined up, then your 5 and your 7 lined up, and then nothing is over top of that next 5. What could be there if I felt like writing it? Another 5. So I'd like you to do that to make sure that you have the same number of decimal places in the number on top and bottom. Hopefully now you can see, do 7 and 1 completely cancel out? No. Do the 5 and 7? No. Do these 5s cancel when I subtract? Yes. And the 5 after that, and the 5 after that, and the 5 after that. All the way to all of eternity, the 5s would all cancel out. So everything to the right of this line will disappear, leaving us with $1.75, take away 17 cents, which is $1.58. So we have 1.58 when we subtract. If you don't know how to do the mental math and you want to type it in, just type in 1.75 minus 0.17. Okay? Finally, you divide both sides by 9, and you get 1.58 over 9. Most teachers that I know who are math teachers don't like decimals mixed in their fractions. That's not really a proper way of writing a decimal. So what you typically do to get rid of a decimal, it's not typically how you write a fraction, sorry, with a decimal in it. What you typically do is you multiply top and bottom by whatever power of 10. Powers of 10 are 10, 100, 1,000, 10,000, 100,000. Those are powers of 10. You multiply by whatever power of 10 will get rid of the decimal. So I multiplied the top by 100, so you multiply the bottom by 100, leaving you with 158 over 900 that reduces to 79 over 450. Because both of those numbers are even, you can cut them in half. Now, right at this point here, you could have done this, if you'd like me to show you a little shortcut. Here it is. Actually on the screen, but here we go. 1.58 divided by 9. Hit enter. That's good news. It's 0.175 with the 5 repeating. That's good. Then you can hit math, fraction, enter, and it confirms that 79 over 450 is the reduced form. Okay? I'm going to finish up problem number 8 now by doing the middle problem in green. And in this case, we take away the 1x from the left, while you take away the 0.175 repeating on the right. And these problems are a little cleaner, because the 0.175 completely matches up, right? Everything here is going to cancel. The 1, the 7, the 5, 175, 175, all the way forever will cancel out, leaving you with 175 equaling 999x. When you divide by 999, you get 175 over 999, which I believe is reduced. You can't go any lower than that. You could confirm that on the calculator by typing this in, and then the math fraction feature that we have. This one is just 175 thousandths, because this is the 10th, 100th, 1000th place. You learned that in elementary school. And that can be reduced because top and bottom are both divisible by 25. How many quarters are in $1.75? 7. How many quarters are in a roll of quarters? $10 is a roll of quarters. 40, yeah. 25 goes into 100 40 times. It's 7/40. You can check your work with these by simply typing in 7 divided by 40. As soon as we get rid of the ink. 7 divided by 40 should be 0.175. Okay? That's it for number 4, right? Number 4?